This is trying to show is how orbits form in sort of Einstein's way, which is that space and time are warped by big objects. So what this is simulating that there's a black hole or some sort of massive object in the center of the sheet, and the sheet represents space-time. And the massive object, black hole, whatever, is warping space-time. So what that warping is it's the curvature. And that curvature makes things move in these odd curved paths that wouldn't really be apparent why that's happening if you looked at it and it's flat, which is what it looks like. So this is really just a way to visualize what's happening in space when objects get in an orbit. They go around these objects and they're really trying to stay in a straight line, but the space they're moving in is curved. And that means that they're going to follow curved paths, even though from our perspective, they should just be moving straight. Newton saw the same problem, and he just said, oh, there's a force, that force is gravity, but he couldn't really come up with why that force happened. Einstein said, no, there's really no force. What's happening is the mass of an object is just so much that it's really warping the space-time continuum, and these objects are trying to move in straight lines in that. And what we're interested in is, how we can visualize what's actually going on when objects attain orbit, so that we can better understand why they're moving in the ways that they are, and how those objects will interact with space.
Thank you. What is your favorite part, and how did you come up with the idea for this project? It's a general an analogy in physics. Whenever they teach you about space-time, they're always like, imagine that it's a sheet and there's a big ball in the sheet. But we really just wanted to show that because it's a really good idea. It works obviously very well. So we just wanted to make that so that everyone could really see what's going on. The favorite part is just trying to get the balls to do different things. Like you can make them go in nearly circular orbits or really elliptical orbits. You can try and hit them. You can just throw a bunch of them at once. That's always really fun. It's really great, and kids really love it, and they love to just wreak havoc on this. But yeah, it's a great hit with everyone else too, because it's just engaging to watch for some real reason that no one knows. And then it gives everyone else to able to interact with it too, because some of the other exhibits. Yeah, it's as opposed to just something that's one-on-one with the designer. You've got one presenter who can present to 20, 30 different people, even if we get that many, and everyone just really enjoys playing around with the marbles. What can I say? But yeah, childhood pastime.
You can say that, but don't judge until you've actually done it.
Can I try it? I was gonna say, can I try one?
Yeah, go ahead. Take one. You don't need to throw it. Just toss.
Just toss?
Yeah, no, not that hard.
Ooh.
Everyone does that.
Sorry.
Little light. Yeah.
Oh.
Too much. You'll get it. Third time's the charm. There you go.
Phew. I succeeded.
Yeah. Let's do them all at once now. This is what everyone comes to see. That's the fun part. That's what everyone comes here to see. Oh.
Uh-oh. Ooh, that one's still going. Thank you for showing us your project.